Hello everybody, welcome to today's video. The video is of data question. Remember, we are still continuing with the biology series, and I'll be honored to present this video to you. It's quite in the evening. You can see I look dark, but all the same, I've decided to present this video to you. Welcome, guys. This video is about the data question of Biology Paper 2, 2006, KCSE. And I'll begin by highlighting what the video was all about. And the first statement there is how hormones affect lateral bud growth. And we ask ourselves, ever wondered why plants grow differently when you prune them? Watch as we review the hidden power of hormones in shaping plant growth. Faster, taller, and stronger branches with just one simple change. By the end of this video, you understand how simple changes in plant hormone levels can dramatically alter the way plants grow, giving you a deeper insight into plant biology and potential strategies for optimizing growth in your own plants. This experiment bridges the gap between theoretical plant biology and practical application. Whether you are a student, a biology enthusiast, or a gardener, you gain a hands-on understanding of how manipulating hormones can impact plant development, ready to uncover the science that powers growth in nature. Let's dive in. An experiment was carried out to investigate the effect of hormones on growth of lateral buds of 3 pea plants. The shoots were treated as follows. Shoot A, apical bud was removed. Shoot B, apical bud was removed and gibberellic acid placed on the cut shoot. Shoot C, apical bud was left. The lengths of the branches developed from the lateral buds were determined at regular intervals. The results obtained are shown in the table below. Using the same axis, draw graphs to show the length of branches against time. So that is the table where we have length of branches in millimeters and time in days. We have shoot A, shoot B, and shoot C. Days are in intervals of 2 days. So at the beginning in shoot A, the length of the branch was 3, and shoot B was 3, and shoot C was 3. After 2 days, The length of the shoot A was 10, B was 12, and C was 3. Day 4, shoot A was 28, B was 48, and C was 8. Day 6, shoot A 50, B 90, and shoot C length was 14. Day 8, 80 for shoot A, 120 millimeters for shoot B, 20 millimeters for shoot C. So when you add the totals, we have 10 days. The total length of the branches in shoot A was 118, shoot B 152 millimeters, and shoot C 26 millimeters. So we have the step-by-step explanation on how to draw the graph. So step number 1 is you prepare your data. You need to have the following data ready for each shoot. Time in days. This will be in the x-axis. Length of branches in millimeters. This will be in the y-axis. Example data from the experiment. Time in days is 0, 2, 4, 6, 8, 10. Length of branches for shoot A, B, and C as provided in the table. Draw the axis on the graph paper provided in the question paper. You draw 2 perpendicular lines to represent the axis. The horizontal axis or x-axis will represent time in days. The vertical axis or y-axis will represent the length of the branches in millimeters. Label the axis, number 3. Label the x-axis as time, days, and the y-axis as length of branches in millimeters. Choose appropriate scales for both axes based on your data. For example, for the x-axis, time in days, you can use an interval of 2 days. Choose appropriate scales for both axes based on your data. So guys, there was an interruption there. Somebody called with a phone. Therefore, and just said that you choose appropriate scales for both axes based on your data. For example, for the x-axis, time in days, you can use an interval of 2 days. For the y-axis, length in millimeters, choose a suitable scale in the intervals of 20 millimeters, considering the range of your data from 3 millimeters to 152 millimeters. Plot the data points. For each shoot A, B, C, plot the corresponding points on the graph based on the time and the length data. For shoot A, plot the points 0, 3, 2, 10, 4, 28, 6, 50, 8, 80, and 10, 118. For shoot B, plot the points 0, 3, 2, 12, 4, 4, 8, 6, 9, 10, 8, 120, and 10, 152. For shoot C, you plot the point 0, 3, 2, 3, 4, 8, 6, 14, 8, 20, and 10, 26. Join the points with a line. After plotting the points for each shoot, connect them with a smooth line or a straight line, whichever fits the trend of the data. Use different colors or markers, e.g. circles or squares or triangles for the lines representing the 3 shoots to differentiate them. And arranged or key include arranged on the graph to label the 3 different shoots. Shoot A, apicomband removed. Shoot B, apicomband removed and gibberellic acid added. Shoot C, apicomband left. Title your graph. Under title at the top of the graph, such as effect of hormones on growth of lateral bands. Once all these steps are complete, your graph will show how the growth of the lateral bands in the 3 plant shoots change over time. So that is the graph to show the length of branches against time. Time in days, axis labeled have a mark. Scale have a mark on the y-axis. Scale have a mark. Length of branches in millimeters have a mark on the y-axis. Plotting of the graph of shoot A, plotting a mark. Identity of the graph have a mark. Smooth curve have a mark. And the same for both shoot B and shoot C. This one graph is generated, computer generated, and look at the way it looks like. You have the region there of the colors. Shoot A, apicomband removed, you can see it there, that color there. Shoot B, apicomband removed plus gibberellic is there, you can see it. And then you have shoot C, apicomband left. Length of branches, millimeters, time days. So this is generated to compare. Note, more than one graph, I want for first graph only, maximum 2 marks. Inverted graph, I want identification marks only. Missing origin, I want for 1 scale only. If ruler used to join points, deny curve marks. Broken lines for curves, reject curve. If curve goes outside grid, reject curve scale. Plotting marks, I want for axis and identification. Round half marks to nearest upper whole number. Response to the questions. What was the length of the branch in shoot B on the 7th day? 105 plus or minus 1. So the values would be 104, 105, or 106 millimeters. What would be the expected length of the developing from shoot A on the 11th day? 140 millimeters, 134 to 140 millimeters. Account for the results obtained in the experiment. In graph A, the tip of the shoot, which was removed, contained auxins, acetic acid, which causes apicodominance or inhibits growth development of more lateral bands. Hence, lateral bands sprout or grow. B, the gibberellic acid, which added on the cut, promotes formation or growth of lateral branches on the stem, hence faster growth of branches on shoot B. Shoot C, the shoot tip which remained intact, contains IAA or auxins, which inhibits growth or development of lateral bands, hence little change in length or growth of lateral branches. Why was shoot C included in the experiment? This was the control experiment. What is the importance of gibberellic acid in agriculture? Increase productivity, accept increased yield of fruit or tea leaves. State two physiological processes that are brought about by application of gibberellic acid on the plants: cell division and cell elongation. The effect of hormones on lateral bands, practical uses in daily life. Hormones play a crucial role in the growth and development of plants, specifically in controlling how lateral bands grow after pruning or cutting. Here is how understanding the concept is applicable to everyday life. Gardening and landscaping. Pruning for optimal plant shape. When you prune a plant, you are essentially removing the apical bud, which produces a hormone called auxin. This hormone inhibits the growth of the lateral bands. By removing it, you encourage the side branches to grow, leading to a fuller, bushier plant. Understanding the hormonal control behind this helps you prune your plants effectively for aesthetic appeal. Boosting plant growth with hormones. Plant hormones like gibberellic acid are used to promote faster and taller growth. Gardeners use this knowledge to treat plants and encourage more robust growth, particularly in plants that need support to grow healthier and larger. Agriculture and crop production. Maximum crop yields in agriculture. Controlling the growth of lateral bands can help improve crop yields. By understanding how hormones like cytokinins and auxins work, farmers can manipulate plant growth to ensure that more branches and potentially more fruit develop, leading to higher production. Reducing excessive growth in crops. Sometimes lateral bands grow uncontrollably and waste the plant's energy. By applying growth-inhibiting hormones, farmers can manage how plants allocate resources, ensuring energy is focused on producing fruit or flowers rather than unnecessary branches. Houseplants and indoor gardening. Encouraging fuller indoor plants. Indoor plants often grow reggae with tall stems but few side branches. You can control this by removing the apical band to stimulate lateral band growth. Knowing the role of hormones helps ensure you get bushier, more attractive plants indoor. Supporting delicate plants. For plants that struggle to grow indoors or in low light environments, gibberellic acid or similar growth hormones can be applied to strengthen stems and branches. This application is common for decorative plants that are grown under less than ideal conditions. Forestry and environment. Tree pruning for the forest health. Pruning trees to remove diseased or damaged parts involves the same hormone response. Removal of the apical band triggers lateral band growth, which helps the tree cover and fill the gaps with healthy branches. Flower arrangement and nursery practices. Creating fuller flower baguettes. In forestry, hormone management is used to ensure flowers have strong lateral growth, which allows for more blooms and better arrangements. Nurseries also manipulate hormone levels to produce healthier and more attractive plants for sale. In summary, whether you are managing your garden, increasing agricultural output, or simply tending to your house plants, the effect of hormones on lateral bands plays a vital role in everyday plant care. By understanding how to control hormones like auxins and gibberellins, you can optimize plant growth, creating healthier, bushier plants, better crops, and more beautiful landscapes. So you have the acknowledgements there. Special thanks to ChatGPT, an AI language model developed by OpenAI for providing assistance with creating and polishing content for these videos. Bye bye guys, and see you in my next video.